Good morning, everybody. The following lecture is to add into the list of the lecture videos I have, and we will talk about hyperbola right now. Okay, now hyperbola is best view if you already learn ellipse. Now, when did we learn ellipse? Let's take a look in our study list. You will learn ellipse in lesson 25. You will learn ellipse in lesson 25 and 25. I happen to unintentionally actually stop the recording at that time. So the recording end up being split into two videos. Okay, but parabola and ellipse was studied in lesson 25. So you will watch this in lesson 26. Okay, you will watch this in lesson 26. I plan to do final review there. So take this as lesson 26, and the final review will be considered as a supplemental lesson. Okay, but we will have, I will have another recording on that day. On that day. Okay, now so consider this as lesson 26. Only watch this once you have watched lesson 25. Okay. And the reason I cover this in more details this time is because usually conic section like circle, parabola, ellipse, hyperbola supposed to be covered in intermediate algebra or algebra 2, but it is placed in pretty much the last section, just like in our textbook. Conic section is actually in the last chapter, right? But even in intermediate algebra or algebra 2, conic section usually plays in the last chapter or second from the last. And usually what happened at that time, the class already behind, so the instructor usually skip this chapter or skip some sections. And if they did, skipping one section, there will be hyperbola that they skip. Okay, now, so if you want to review a little bit about hyperbola from intermediate algebra point of view, I suggest you to go back to my lecture video. So if you remember where to get my website, like this is my website, right? arjuno.com. And then you click on my face, and then you go to lecture videos. Under video, you go to lecture videos. Okay, and then you can choose, let's say this one here. No, not that one. I think this one here. Yeah, Math 115, 125, elementary and intermediate algebra. Okay, and then you go to conic section hyperbolas. Then you will see the lecture videos on hyperbolas. But I think even in that case, they give you how to sketch your hyperbola right away without going too much details. So you can use this actually to do your exercise later on, examples. Okay. Or you can also go to, if you go further down, intermediate algebra by Santa Monica. In the past, we used this textbook. You can watch these videos here. Okay, but it's more object-oriented, where they actually ask you to graph hyperbola if they give you the equation. So that's the video, right? Okay. Or if you have a hyperbola and you need to find the equation. Okay, and so on and so forth. So what happened is, if you go back to my lecture videos from my website, you will see more examples. Okay, what I'm going to do right now is to dig more into the technical foundation of hyperbola. Okay, now let's start. What is a hyperbola? Hyperbola is defined to be the set of all points on a plane in 2 dimensions whose difference of distances from 2 fixed points, which we call foci, is a positive constant. Now we will get back to this later at the end. Or maybe not at all, maybe not at all. Okay, but basically, I will give you the glimpse of why we say it this way later on. Okay, but we define hyperbola as the set of points on a 2-dimensional plane whose difference of distances from 2 fixed points is positive constant. Now, there are many ways to teach hyperbola. Okay, and what I do here is to supplement what the common method of teaching, not the common way, but just an alternative way of looking at that. Okay, I break it up into 5 steps of learning. First, hyperbola in relation to ellipse. So we use what we learned before from ellipse and then see hyperbola from that point of view. Okay, and after that, we zoom into a hyperbola and we learn some terminologies in hyperbolas. Okay, and then to find the center, vertices, axis, conjugate axis, and then after that get the auxiliary rectangle and asymptotes, and then finally to compute the foci. Okay, now after those we will do examples. Now let's start. First, from the conic section, we learn about unit circle, right? This is a unit circle. The equation of unit circle is x squared plus y squared equals to 1. That's a unit circle. Now, ellipse was defined as the set of all points in a plane whose distances, sum of distances from 2 points, 2 fixed points, which we call foci, is a positive constant. So for example, this ellipse that we see here, that x squared over 9 plus y squared over 4 equals to 1, that's an ellipse, right? And every point here has the same, we computed we can compute the foci, right? The c squared equals to 9 minus 4, which is equals to 5. So c is square root of 5. The major axis is the x-axis, so square root of 5 is approximately 2 point something. Let's say it's here. That's the foci. That's another foci. Okay. Now, so if I pick any point on the ellipse, then the distance from that point on the ellipse to both of the foci, the sum of this distance here must be the same to, if I pick a point, let's say here, the sum of the distance that you have in a plus b is equals to, let's say, x plus y here. Okay. Or you can also use another, it doesn't have to be the one here. It doesn't have to be the one here. Let's pick the one here. Let's pick the one here. The sum of the distances in red is equals to the sum of the distances in blue. Okay, that's how we define ellipse formally. Now, however, We can also define ellipse in a slightly different ways. Yeah, we can see ellipse as, or you can see that as a unit circle stretch in two direction, in horizontal and vertical direction. Of course, this is a very, very informal definition. So this ellipse here, you see, this is actually, this can be seen as x/3 squared plus y/2 squared. So from here, we see that we stretch horizontally in x direction by factor of 3 from the unit circle. Right? This is the unit circle, right? You stretch that by factor of 3 horizontally and by factor of 2 vertically. Okay, we can also see it that way. That's what I'm saying. That's what I'm saying. Okay, now we are not talking about ellipse this time. That's just a little review. Okay, but we see that an ellipse has a common pattern. The standard form is x squared over a squared plus y squared over b squared equals to 1. Okay, and if a squared is greater than b squared, then it is the major axis is parallel to x-axis, right? Otherwise, if a squared is less than b squared, then the major axis is parallel to y-axis. Okay, so here the denominator of x squared in this case is 9. That's the a squared. A squared equals to 9 is greater than b squared, which is 4. Therefore, the major axis, the longer axis, is parallel to x-axis. Now, what I will do next is to change this equation using the same pattern, but the one that gives us a hyperbola. Okay, let's see the first one. I hope you can see the coloring here. The purple color is the one give us the ellipse. Okay, if I change the plus sign becomes minus sign, then I will get a hyperbola. Okay, now the hyperbola here is a left and right branch parabola, hyperbola. We will say that this hyperbola is has the axis parallel to x-axis. Okay, the axis of this hyperbola is parallel to x-axis. It opens left and right. Okay, now how do we know later on, Thomas, if the hyperbola is actually parallel to x-axis or y-axis? We will look at the first term. Okay, if the first term starts with x squared, then it is parallel to x-axis. Okay, now, so you notice that x squared over 9 plus y squared over 4 equals to 1 can also be written as y squared over 4 plus x squared over 9 equals to 1. These are two exactly the same ellipse, right? But then if I change the plus sign on the top here becomes minus, that's what we get. The hyperbola opens left, right. Now, on the other hand, if I change this one here, if I change this plus sign becomes minus, but the y squared at the front, you expect, let's say this is the ellipse, you expect the hyperbola to be opens up down. Okay, if I change this plus sign becomes minus. Okay, then we say that the axis of this hyperbola, the one in green, is parallel to y-axis. Okay. Now, you can see that actually in the next graph. You see that that's the same the ellipse that we have earlier, x squared plus 9 plus y squared over 4, that give us this purple ellipse, right? But then if I purposely write the y squared over 4 at the beginning minus x squared over 9 in my second term, my next term, then the hyperbola, as we said earlier, will be open up down, where the axis of that parabola is actually parallel to the y-axis. Okay, so let's review a little bit. Let's review a little bit. So if we see x squared over a squared minus y squared over b squared equals to 1, then the parabola will be open left, right. Okay, and it is the axis of that parabola is parallel to the x-axis. If we have y squared over b squared minus x squared over a squared, where you see the y squared, actually we start with y squared term minus the x squared term, then it will be up down. And the axis of the hyperbola is parallel to the y-axis. Okay, now let's put things together. Let's put things together. You see, the one in purple, do I have a purple color? Oh, I guess I used the black color. Okay. I really thought that I already changed that too. Yeah, the one in purple, the equation is x squared over 9 plus y squared over 4 equals to 1. And you see that x squared over 9 means the origin is 0, 0, x squared and y squared, right? The center is origin. And then you go 3 units to the right, 3 units to the left, because we have y squared over 9. You see that as x over 3 squared over y over 2 squared plus y over 2 squared equals to 1. Or you can also see that as x squared over 3 squared plus y squared over 2 squared equals to 1. That's just different ways of writing it, right? But from there you see that the center is origin. You go 3 units to the left, right, and 2 units up, down to get that ellipse. Right? Okay, now then what happened if we have the blue one? Let me write it in blue. In blue, that's x squared over 9 minus y squared over 4 equals to 1. So you see that if you have x squared over 9 minus, then these points here will coincide. Okay, we call that the vertex, right? The major vertex for the ellipse that correspond to the left and right coincide with the vertices of the hyperbola. Okay, and the one in red, as you expect, is y squared over 4 minus x squared over 9 equals to 1. Okay, now the vertices of the hyperbola coincide with the vertex of the ellipse, vertices of the ellipse, the one that on the top and the bottom. Okay, because this is y squared minus x squared part, then we know that the hyperbola will be up down, right? Okay, the blue one, because it starts with x squared minus y squared, then it will be left right. Okay, where are the vertices? Where are the vertices? Then we can go back to ellipse to see that. Okay. So let's practice a little bit. Let's practice a little bit. Okay, let's practice a little bit. Suppose for example, just small examples. Suppose I have x squared minus y squared equals to 1. Because it starts with x squared, you know it will be left right. Right? Okay, where are the vertices? Here. Where are there? Okay, to find out, you can think of that. Think of x squared plus y squared. You know what? Let me change the color. You can think of x squared plus y squared equals to 1. Okay, you change it to plus sign. What's the graph? Oh, that's actually a unit circle, right? That's actually a unit circle. Okay, now because it is left right, then the vertices of that hyperbola must be here. Open left and open right. You see that? Okay, so not only we know that it opens left right right now, we know the position of the vertex. Okay, now let's go back to the second part, terminologies. Terminologies. We implicitly have learned the word vertex. This point and this point here are called the vertices. Vertex. That's also a vertex. Okay, now I will call this as the center. Actually, that's a common term. We call that the center of the ellipse. And as you can see, the center of the ellipse, the center of hyperbola will be the same. Okay, the center of the ellipse, the center of the hyperbolas must be the same. Okay. Next, the axis of the hyperbola is here. What color should I use? Let me use this color. This is the axis. The axis of hyperbola. To be more precise, this is all called transverse. I think transverse, no transverse. Let me see the correct word. My English is bad. Transverse axis or transverse axis? Let me take a look. Give me a second. Transverse axis, so I'm right. So the one in highlight blue here, blue or green, is called transverse axis. And the one in green, is called conjugate axis. Okay, now don't forget that this conjugate axis and transfer axis are actually the major and minor axis of the ellipse. If you have an ellipse here, right? If you have an ellipse there, then the transverse axis will be the same to our major axis in ellipse. The conjugate axis for the hyperbola is the same to the minor axis in ellipse. Okay, that's why again I actually would like to talk about hyperbola from ellipse point of view. Okay, now if the hyperbola is actually opens up and down like this, then the transverse axis will be the one here. That's the transverse axis. Okay, this is transverse axis, or we can simply call that the axis. Okay, while this is the conjugate axis. Okay, the vertices are these two guys here. Now, how do we know that the position of the vertices? Yeah, take a look on the first term. Okay, so that's actually y squared over 2 squared minus x squared over 3 squared equals to 1, right? Now, from the numerator, you see that the center is 0, 0. The center is origin. Okay, and then vertices is 2 units from center. Okay, now the thing is 2 units from center. How do we know we go up or down, or we go left or right? It depends on the transverse axis. Okay, the transverse axis here is parallel to y-axis. So we go from the center, you go up 2 units, down 2 units. Okay. Now, let's put more things together. Okay, let's put more things together. Let me redraw this. So this is our conjugate axis. And, this is our transverse axis, or simply axis. Let's put things together. So let's look back. The one in green, the equation of the one in green, that's the ellipse, right? That's the ellipse. The equation is the center is origin. You go 3 units to the right, 3 units to the left, up to down 2. Because 3 units to the right and left, x squared over 3 squared, up to down 2 plus y squared over 2 squared equals to 1. Now, the one in red, it's 3 units to the left, right, from the origin. Okay, so it must be x squared minus y squared because it opens left, right. Right, the transverse axis is x-axis, so we start with x squared. Okay, now the vertices is 3, 0, negative 3, 0, 3 units from the center. Okay, now how do we know from that picture? How do we know from this picture that it will be y squared over 2 squared? Yeah, it really depends on the ellipse that gives you that hyperbola. Okay, depends on the ellipse that gives you that hyperbola. Now we'll go deeper into that later on. Because in reality later on, what happens if you don't have the ellipse like this, right? How do we know? We know from here that must be y squared over 2 squared, but how do we know that it will be x squared minus 3 squared? How do we know it's over 3 squared? Okay, that's something we will do later on. Don't worry about that. Let's talk about this first. The one in blue, that will be up and down, right? So the transverse axis is y-axis. That will be y squared over 2 squared because the vertices are 0, 2, 0, -2. Okay, minus x squared over something we don't know yet if we only look at the blue part. Okay, now here, because we already have the ellipse, then we know, oh, it must be over 3 squared. Okay, now what is auxiliary rectangle? Auxiliary rectangle is actually this rectangle here. This rectangle. That's auxiliary rectangle. The rectangle in black is the auxiliary rectangle. Okay, notice that this auxiliary rectangle is the one put this ellipse and two corresponding hyperbolas. Okay, now, furthermore, we will have asymptotes. What is the asymptotes? You see that this hyperbola actually has an asymptote approximately here. This is one asymptote, and this is the other asymptote. You see that the asymptotes always passes the asymptote always passes the vertices of the rectangle, the diagonal vertices of the rectangles. Okay, the asymptotes pass the diagonal vertices of auxiliary rectangle. Okay, now you see that, for example, this vertex here, this vertex there, what color should I use? Oh, I use this one. So this, the corner of this auxiliary triangle rectangles has coordinate 3, 2. And apparently it actually goes through the origin also, right? And it also passes through -3, -2. Okay, now you will see that the equation of this asymptote will be y equals to 2 over 3x. Okay, Or if I write it in a strange way, that's y over 2 equals to x over 3. How about that? Do you see that? Y over 2, x over 3. Y over 2, x over 3. Y over 2, x over 3. Do you see that pattern? Y over 2, x over 3. Okay. So you see that the asymptotes has something to do with the rectangle, and the rectangle has something to do with all those ellipse and two hyperbolas, right? Okay. Now, in fact, the asymptotes for this one here has vertices 3, -2, and this one is -3, 2. So the equation of this asymptote will be y equals to -2 over 3x. Or we can also write that as y over 2 equals to -x over 3. Okay, now, so we can summarize the following. So for example, if I have y squared over, let's say, 5 minus x squared over 4 equals to 1. Oops, not 0. Equals to 1. Then what will the asymptotes be? The asymptotes will be y over square root of 5 equals to plus minus x over 2. Or y equals to plus minus square root of 5 over 2 of x. Those are the asymptotes. Okay. Actually, let's use this example here. Let's use this example here. So example one, let y squared over 5 minus x squared over 4 equals to 1. And we want to sketch this. Okay, we want to sketch this. So what's the center? As you can see, part A, the center is 0, 0. Okay, and then because we start with y squared, then the axis or transverse axis is parallel to the transverse axis is the y-axis itself. Okay, so if I try to sketch the graph, then the transverse axis will be here. Okay, this will be the center. Okay, and then the vertices are radical 5 from origin along the axis or along the transverse axis. So we go radical 5 up, that's approximately 2 point something, and radical 5 down. Okay, so this will be, the vertices here will be 0, radical 5. And this will be 0, negative radical 5. Is it okay? Those are the vertices. Okay, now how about the asymptotes? The asymptotes will be y over radical 5 equals to plus minus x over 2. Now, of course, we don't really write the equation of asymptotes that way. Okay, so we rewrite that to be y equals to plus minus radical 5 over 2. That's the slope of x. Okay, the first one is the radical 5 over 2x, radical 5 over 2x. So radical 5 up 2 units to the right. So that's 1 asymptotes. This is y equals to radical 5 over 2x. Okay, and the other one is the negative one, the negative slope. Okay, this is y equals to negative radical 5 over 2x. Okay, you can see that this is actually the auxiliary triangle rectangles. That's the auxiliary rectangles. Okay. And if you imagine the ellipse actually like this. But we are not graphing ellipse right now. Yeah, but this ellipse is y squared over 5 plus x squared over 4 equals to 1. Okay, that's the equation of the ellipse. Now, go back to the hyperbola. So what's the hyperbola? The hyperbola will be, let me make it in blue. This is the vertex and it goes to the asymptotes. Okay, gets closer and closer to the asymptotes. Okay, not intersecting though, not intersecting. So that will be the hyperbola. Okay. Now that's for this one example. Okay, let's do more. Let's do more. Let's say for example number 2. Example number 2. Let x squared over 7 minus y squared over 3 equals to 1. Okay, so how do we graph this? Okay, we are still missing one big component of this hyperbola though. If we look back, we are still missing the foci. So I did explain auxiliary rectangle and asymptotes. We still need to look for the foci. Okay, but we'll do that after this last example. Okay, so first one here, because we have x squared, y squared, then the center is 0, 0. Okay, it's origin. Okay, the transverse axis or the axis is parallel to x-axis. Instead, because the center is origin, then the transverse axis must be the transverse axis must be on the x-axis. Okay, in fact, the vertices are radical 7 away from origin along the major axis, along the transverse axis. So radical 7, 0, negative radical 7, 0. Okay, radical 7 is a bit more than 2, so it's here. Okay, those are the vertices, right? And then how about the asymptotes? The asymptotes are x over radical 7 equals to plus minus y over radical 3. Now, we usually don't write it that way though. Okay, we usually write that as y equals, right? Okay, so if I modify this, this will be y equals to plus minus radical 3 over radical 7 of x. Rationalizing the denominator, that's y equals to plus minus radical 21 over 7x. Okay, so let's picture that. Radical 3 is 1 point, I think it's 1.7, approximately 1.7. So our auxiliary rectangle is here. Okay, let me mark the vertices first. This is radical 7, 0. This is negative radical 7, 0. Okay, this is 0, radical 3. And this is 0, negative radical 3. So the asymptotes will be approximately like this. Okay, this is y equals to radical 21 over 7x. This is y equals to negative radical 21 over 7x. And because we start with x squared term subtracted by y squared term, then the hyperbola will open left right. The hyperbola will open left right. Okay. Now last part, how about foci? So part E, how about the foci? Okay, now foci is the points, the fixed points that we talked about earlier, the two fixed points to which the difference of the distances from any point of hyperbola on the hyperbola to be a fixed positive constant. Okay, and that is denoted by C, where the distance, the difference of the distance, C, where C squared equals to A squared minus B squared, or C squared equals to B squared minus A squared, depends on which is larger. So we can also say that C squared equals to absolute of A squared minus B squared. Okay, we can say so. Okay, now, if we look back to the pictures, from the very beginning, okay, focus, we have, actually, I think I write it wrong. Yeah, I wrote it wrong. So the focus are here, right? These are the focus here. The coordinate C here is equals to, coordinate C here is equals to A squared minus B squared. Okay. And of course, this is the negative of that. This is c squared equals to a squared minus c squared. Now, the position of the foci of hyperbolas are actually here, somewhere around here. These are the foci, or maybe here, but basically on the left, right. Okay, it is along the transverse axis also. So on the transverse axis, you will have the center, you have the vertices, and you will have the foci. Two focuses, right? Focus, the plural form of focus is foci. Okay, now the position are on the transverse axis. The equation, however, how far is the foci from the center, that will be defined as c squared equals to a squared plus b squared. Okay, a squared plus b squared. Actually, you can see it this way. If you have a rectangle here, right? If you have a rectangle here, the distance from center to C is the same to the distance from center to the one of the vertex of the rectangle. Okay, so you get the vertex and then you drop it down. So it should be around here, I believe. Okay. Now let's get into details there. Let's get to details there. Let me correct the one I wrote down here first. So it's supposed to be plus, not minus. Minus if you have ellipse, plus if you have hyperbola. Okay, so I don't actually need the plus minus. I just need this. Okay, so if we have x squared over a squared minus y squared over b squared equals to 1, we know that the hyperbola opens left, right, center at origin, and the transverse axis is x-axis, right? Then the coordinate here will be a comma 0 and negative a comma 0. Is it right? Okay, while the foci are located here. The coordinates will be c comma 0 and negative c comma 0. Okay, where the c squared equals to a squared plus b squared. Okay, the c squared equals to a squared plus b squared. Now, if we look back, oh, you know what? So what happened if we start from y squared, Thomas? So if we have, well, y squared over b squared minus x squared over a squared equals to 1, then the hyperbola will be the hyperbola will be along y-axis, right? Parallel to y-axis. The center is origin. Okay, the hyperbola will open this way, up and down. The vertices are 0, b and 0, negative b, right? And the foci will be 0, c and 0, negative c. Same thing, that c squared equals to a squared plus b squared. Okay. Now, actually look back. Let's look back to our examples above. Okay, these are the foci of an ellipse, right? Now, c squared is a squared minus b squared. So c must be less than a. Now, what if we have this one here? If we put into computation, the actual computation, c squared equals to 9 plus 4. Notice that 9 is already a squared. Okay, 9 is already a squared. This is position of a squared. A squared, the a squared is 9. Okay, and the b squared is 4. Okay, so c squared equals to 13. So c equals to square root of 13. That's less than 4, more than 3, approximately here. Approximately there. Okay, so the focus will be square root of 13, 0, and negative square root of 13, 0. Okay. If we go on further, the one here, you notice that it comes from the same ellipse, right? Okay, so the vertex is c squared equals to, again, 4 plus 9 equals to 13. So c equals to square root of 13, but the foci will be between 3 and 4. So this is 0, radical 13, 0, negative radical 13. Okay. If we put everything together, notice that the vertex, the foci for the blue one is here, approximately, right? And the foci for the red one will be here. I'm sorry, I take it incorrectly. Notice that the foci of a hyperbola and the conjugate hyperbola will be in the same circle. Okay, the conjugate, the foci for the blue hyperbola is here. You see that is inside the yellow circle. The foci of the red hyperbola also inside, is also on the yellow circle. Okay, and this yellow circle passes through the auxiliary rectangle. Okay, so many things put together, huh? Okay, don't worry about this for now. Actually, I want to erase that one also. Too much information I put back there may be confusing for a lot of you. So let me erase this, erase this, erase this. Yeah, only those who watch the videos will get it. Okay, so let's go back to our example then. Let's do the last example first, the last example. So where is, so going back here, where is the focus, foci? C squared equals to 7 plus 3. That's equals to 10. So C equals to square root of 10. That's square root of 10 units from the center of that hyperbola. The center of hyperbola 0, 0. So I go to the right and to the left. That's square root of 10 over comma 0. And this is square root of negative square root of 10 comma 0. Those are the foci. Okay. How about example 1? Where is the foci? The part E, foci, c squared equals to 5 plus 4, which is 9. So c equals to 3. That's 3 units from the origin along the main axis. So there'll be 0, -3, 0, 3. Okay, now those are the examples. Let's go to a situation where we have the general form. So we basically do everything right now. Okay, start from the very basic one. Suppose we have from our textbook question number 4. This is from textbook. What we will do, we will answer all possible problems from a given equation. So we have in number 4, x squared over 49 minus y squared over 16 equals to 1. We need to find the center, the vertices, the foci, the equation of the asymptotes, and sketch. Okay, so the first one, what's the center? We usually don't ask that question though. What's the center? The center is origin. Okay, the vertices, it's 49 is for the one a squared. That's the one under x squared, right? So that's 7 units. To the left, right. 7, 0, -7, 0. So if I sketch that, the center is origin 0, 0. And because we start with x squared term, we'll go 7 units to the right and 7 units to the left. Okay, to help us with the auxiliary rectangles, then we have these rectangles. How far do we go up and down? This will be 0, 4. This will be 0, -4. Right. So later on, our asymptotes will be here. That's these are our asymptotes. Okay, and then the foci will be c squared equals to 49 plus 16. That will be 65. Slightly, so c equals to square root of 65. That's slightly more than 8. That's slightly more than 8. So the foci will be slightly more than 8. So let's say it's here and here. That's square root of 65, 0 and negative square root of 65, 0. So the hyperbola looks like this later on. How about the asymptotes? The asymptotes will be x over 7 equals to plus minus y over 4. But we need to write that in slope-intercept form. So it becomes y equals to plus minus 4 over 7x. Okay. Now, let's sketch this in more detail. Let's sketch this in more detail. Let me grab a coordinate system. Give me a second. The devil is in the detail though. Let me put the coordinate system here. Okay. Make it a bit smaller so that it fits into the picture. Okay, let's put the details. So the center is 0, 0. The vertices are 7, 0 and negative 7, 0. Those are the vertices. The asymptotes are plus minus 4 over 7x. So up 4, right 7. Up 4, right 7. And up 4, left 7. So the asymptotes will be like this. Let me pull this further. And another one. Okay, so and the foci will be slightly more than 8. Slightly more than 8. Let's say here, square root of 65, right? But the hyperbola will be something looks like this. Okay, approximately. Okay, now I will take a little break, but let me explain about the distances. Let's use the following. Give me a second. I want to explain our definition a little bit. Now, this hyperbola has the equation of x squared over 5 minus y squared over 4 equals to 1. Okay, now I will explain the idea of the definition of that hyperbola. We see that the c squared equals to 5 plus 4, which is 9. So c is equals to square root of 9, which is 3. From the center origin, you go 3 units to the right and 3 units to the left. Those are the foci, right? Now, we said earlier that a hyperbola is the set of all points such that the distance, the difference of the distances from two foci are fixed, positive, constant. Okay, so let's pick this point here. Let's pick this point on the hyperbola. And let's say the distance here is d1 and this is d2. Okay, now you will see d1 minus d2 is equal to, even if you pick a coordinate from, let's say here, the distance from that point, oops, it's ugly, I know. to both of the foci. Okay, if I call this D3 and this is D4, then D1 minus D2 is equal to D3 minus D4. Now that's what we meant by the difference of the distances is constant. Okay, whatever point you pick on this hyperbola, whatever point you pick from this hyperbola, including this one here, the vertex, right? Then the distance from both of the foci, let's call this D5 and this is D6, right? That will be constant. In fact, we know what's the distances, the difference of the distances. What are those? You see that D5 is actually twice the A, twice of radical 5, right? Plus C, I'm sorry, this is A and then plus C, to be more precise. The distance here is A, radical 5, and the distance here is 3, right? Minus this thing here. But this D6 is actually 3 minus radical 5. Okay, so that's radical 5 plus 3, that's the D5. The D6 is 3 minus radical 5. That's equals to 2 radical 5. Twice radical 5. Okay, in other words, the difference of D1 minus D2, the difference of that distance is equals to the distance between the vertices. Okay, the difference between D3 and D4 is equals to the distance between two vertices, which is the green ones. Okay, now maybe I write a note here. Watch the recording. To understand this sketch, to understand these notes. Okay, I will take a little break. I will continue from here later on after the break. We will continue with working on problems from our textbook and slowly moving into more and more complicated situation. Okay, let's take a break. I will come back at 9:35. Okay, let's continue. We will do question number 8 from our textbook. This is not in standard form. The reason is it's supposed to be equals to 1. Now it's equals to 8. So how to make it equal to 1? We will divide by 8. If we divide by 8, then we'll get x squared over 8 minus y squared over 4 equals to 1. Right? Okay, now then from there we go on. What's the center? Let's call that part A. The center is 0, 0, because we have x squared and y squared. Okay, how about the vertices? That's the square root of 8, right? From center So the vertices will be square root of 8 comma 0, negative square root of 8 comma 0. We can simplify that to be 2 radical 2 comma 0, negative 2 radical 2 comma 0. How about the foci? C squared equals to 8 plus 4, that's 12. So C equals to square root of 12 or 2 radical 3. That's along the vertices also. Okay, the major axis is x-axis. The transverse axis is x-axis. So there will be 2 radical 3 comma 0, 2 radical, negative 2 radical 3 comma 0. Is it okay? If I use my coordinate system, give me a second. If I use my coordinate system, then the vertices are square root of 2 times 2, that's 2.83, 2.8, so it's approximately here. Those are the vertices. Okay, and the foci will be square root of 3 times 2 away from the center. That's approximately 3.5. So the foci will be approximately 3.5. Okay, how about the asymptotes? Will be x over square root of 8 equals to plus minus y over square root of 4, which is 2. So y equals to plus minus 2 over 2 square root of 2y. So y equals to plus minus, that's radical 2 over 2y. I mean x. Okay, the auxiliary rectangles will be approximately here. That's the auxiliary rectangles. So the asymptotes will be here, approximately. It's a bit off here. Okay, now then sketch of the graph will be, what color do I want to use? Let me use blue. So it will be like this. Okay. That's the sketch of the graph. Not a nice one though. I know it's not a nice one. But the one that you need to put, oh yeah, if you are not using graphing paper in your tests, I do expect you to write down the coding. So this one here will be 2 radical 3 comma 0. This is negative 2 radical 3 comma 0. For the vertices, this is negative 2 radical 2 comma 0. This is 2 radical 2 comma 0. And as for the asymptotes, that's y equals to radical 2 over 2x. This is y equals to negative radical 2 over 2x. Okay, yeah, I do expect you to give me such details. Okay, let's do more. How about if we do number 10? Number 10. What I go over here is actually still at the level of intermediate algebra. So if you find it to be hard, not yet, not supposed to be hard yet. Okay, not supposed to be hard yet. Okay, this is already in standard form, but we have issue here. Let's rewrite this into the standard form y squared over 1 minus x squared over 1 over 16. That's actually the standard form. Okay, then from there we see first the center is 0, 0 still, right? And the vertices, that's square root of 1. So along the y, however, so that's 0, 0. But because we start from y squared, then we go up and down 1 units. So that will be 0, 1 and 0, negative 1, right? That's the vertices. And how about the foci? That will be c squared equals to 1 plus 1 over 16. That's 17 over 16. So c equals to square root of 17 over 4. 0, square root of 17 over 4. 0, negative square root of 17 over 4. So the foci will be slightly up there. Okay, and then how about the asymptotes? The asymptotes will be y equals to plus minus x over 1 over 4. Which if we simplify, of course, that will give us y equals to plus minus 4x. Now we are ready to sketch the graph. Let's grab the picture. Put it here. The center is origin. The vertices are 0, 1, 0, negative 1. The foci, square root of 17 over 4. That's 1.02. Oh, just slightly above that. It's very, very, oops, sorry. It's very, very close to the vertices. So the red one are the foci. That's square root of, and 0, square root of 17 over 4. this is 0, negative square root of 17 over 4. Okay, and then how about the asymptotes? 4x. It's quite steep, huh? I need to move this a little bit. Okay, the other one. Okay, so the hyperbola will be very skinny, huh? It's very skinny. The hyperbola will be very skinny. And remember, that's asymptote, so it gets closer and closer to the asymptote as we go away from the center. Okay, let's see what's the graph look like if we actually graph it. So that will be y squared minus 16x squared equals to 1. Yeah, that's what it looks like. That's what it looks like. Let's screenshot that. And put it next to our graph earlier. See? Okay. Now let's go on. Let's go on. What happened if the center is not at origin, Thomas? Then that will be just a transformation. Yeah, that will be just transformation from there. Okay, let's take a look on number 12. So this number 12, the center is 3,1. Okay, the center is 3,1. The vertices is square root of 25, which is 5 from center parallel to x-axis. How do we know, Thomas? Well, because we start from x terms, right? But we don't start from origin anymore. So try to imagine it this way. We have 3,1, right? Now move 5 units to the right, 5 units to the left. What do you get? That will be 8,1 and negative 2,1. Is it right? Okay. And how about the foci? Foci will be c squared equals to 25 plus 4, that's 29. So c will be square root of 29. Right now, the foci will be square root of 29 from the center. Okay, think of it this way. That will be 3 plus square root of 29 comma 1, 3 minus square root of 29 comma 1, and just leave it like that. You only need the decimal when you actually sketch them. Okay. Now, how about the asymptotes? How about the asymptotes? That will be x minus 3 over 5. Now take a look where I get that. X minus 3 over 5. Okay. Equals to plus minus y minus 1 over 2. Now from there, then you clean it up. Okay, for example, I multiply by 10. I will get 2 times x minus 3 equals to plus minus 5 times y minus 1. Okay, split them though. Maybe let me distribute first. Let me distribute first. So I will get 2x minus 6 equals to plus minus 5y minus 5. So if I split that, I will get 2x minus 6 equals to 5y minus 5 plus 5. That's 2x minus 1 over 5 equals to y. And 2x minus 6 equals to negative 5y plus 5. 2x minus 11 over negative 5 equals to y. Okay, now the equation seems to be hard to graph later on, but actually using that center and auxiliary rectangles, it will be quite easy. Okay, it'll be quite easy. Now let's try to sketch the graph. In a second. Hope it's not too small though. Okay, so the vertices are, oh, I didn't write it down, did I? The vertices are 8,1 and negative 2,1. So the center is 3,1. This is the center. Oh, it's a wrong position, huh? Let me do it all over. Give me a second. Use this one instead. Yep. Okay, so the center is 3,1. It's here. The vertices are 8,1 and negative 2,1. Okay, and the foci are 3 plus radical 29,1. It's 8.3 something. So the foci are here. Oops. Here approximately. Now, how to draw the asymptotes without getting into that. Sketch the rectangle. Okay, sketch the rectangle. The rectangle is 5 units up, down, left, right, and then 2 units up, down. Right? So 2 units from 1 is 3. So I will use this one here. It's not precise. It should be like this. That's a rectangle. Right? So the asymptotes will be something looks like this. Okay. Now then the hyperbola will be approximately like this. Okay. Now the hyperbola is the blue ones, and the one in green are the rectangle, are the asymptotes. I think I want to put more details about these coordinates here. This will be 3 plus square root of 29, comma 1. This is 3 minus square root of 29, comma 1. Okay, the coordinates here will be 8, comma 1. The coordinates here will be negative 2, comma 1. Okay, and the equation of the asymptotes, we can just leave it like as the following. This is y over 1. I'm sorry, y minus 1 over 2 equals to x minus 3 over 5, while this one here is y minus 1 over 2 equals to negative of x minus 3 over 5. Okay. Now that's if it is not centered at origin. Now let's see a more complicated situation. Let's say we do number 14. This is if we have the equation in general form. This is if we have the equation in general form. So what we need to do, we rewrite that into standard form. Okay, we'll rewrite this in standard form first. And then from there, we will be able to see, for example, the center, the vertices, and therefore the foci and the asymptotes. We will do completing the square. So this will be plus 36, right? So on the other side, I will add 36 also. You know what? Let me use different color. Add 36 to complete. And then the one here, I will factor the 4, negative 4. So I get x squared plus 4x. Is it right? Now, for me to complete that, I need to add 4. Okay, but that means on the other side, I need to add negative 4 times 4. Okay, so not only this 4, but we actually add negative 16. Okay. I'll put things together, then this becomes y minus 6 squared minus 4 times x plus 2 squared equals to 36. Divided by 36 each term, we will get y minus 6 quantity squared over 36 minus x plus 2 squared over, if I divide by 36, this becomes 9. Okay. So what's the center? We read it from there. The center will be very careful. What's the x? What is the y? The center will be negative 2,6, not 6, negative 2. Okay. And the axis is parallel to y-axis. Okay, so negative 2,6 parallel to the y-axis, right? That hyperbola is up-down hyperbola, the top half and bottom, the top branch and bottom branch. Okay, the vertices is 6 units from center. Square root of 36. Okay. So the vertices will be negative 2,6 plus 6, negative 2,6 minus 6, which becomes negative 2,12, negative 2,0. So the vertices are negative 2,12, negative 2,0. How about the foci? C squared equals to 36 plus 9, that's 45. So C equals to square root of 45, which is 9 times 5, that's 3 square root of 5. So the foci will be negative 2,6 plus 3 radical 5. Negative 2,6 minus 3 radical 5. Okay, the foci will be here. Negative 2,6 minus 3 radical 5. That's negative 2,6 plus 3 radical 5. Okay, let's see what the graph will look like. I'm trying to find a good point of view. 1 second. I try to put things together. So the center is 2, negative 6. That's the center. Negative 2,6. I'm sorry. Negative 2,6 is here. That's the center. Okay, and the vertices are negative 2,0 and negative 2,12. Right? Okay, how about the rectangle? The rectangle is 6 up, down, 3 left, right. So the rectangle will be 3, left, right, 6 up, down. Yeah, approximately like this. Okay, so the transverse axis is here, right? That's the transverse axis. The foci will be -2, 6 + 3 radical 5. 6 + 3 radical 5 is 12.7. 12.7, so the foci is approximately here. And therefore, it's approximately here. I still need the asymptote though. The asymptote will be new screen. So approximately like this. Oh, I need to give the equation of the asymptotes, right? I forgot. But that's okay. At least we know what the graph look like first. Okay. Make sure you emphasize from your graph that it doesn't intersect with the asymptotes. Okay, it doesn't intersect with the asymptote. Okay, let's write down the equation of the asymptotes. Part D, asymptotes. Are y minus 6 over 6 equals to plus minus x plus 2 over 3. Okay, those are the asymptotes, the equation of the asymptotes. Okay, and then let's multiply by 6. So y is equals to plus minus 2 times x plus 2 plus 6. So that will be, make sure you split it in this situation. That's 2x plus 10. Y equals to -2x plus 2. Oh, you know what? Do you think it's kind of like not a coincidence? From here, you see the y-intercept is 0, 10. The y-intercept is 0, 2. Dang, that's so nice, huh? Okay. We don't need that, but it's nice to be able to see that relation though. Okay, now I will stop here for the hyperbola. The suggested homework for you will be from number 1 to number 27. I think those are good enough. The suggested homework from 10.3 from number 1 to number 27. Just do the odd ones. Okay, that's for today.